Hello students. Today we shall start differentiability. In the last year you have studied the derivatives and the first principle. What the definition of differentiability is, let us see. Let y is equal to f of x be a continuous function and it is said to be differentiable at a point C if limit of f of c plus h minus f of c divided by h, limit as h tends to 0, exists finitely. This means f of x, suppose f of x is a function, okay, and suppose f of x is continuous at a point C. Now we are going to consider the values f of c plus h and f of c, their ratio, that we call it as the increment given for f. Okay, how is the increment given? F of c plus h and f of c means h is an increment given to x. Thus, an incrementary ratio delta y upon delta x is called as limit x tends to delta x tends to 0 is called as the derivative of y with respect to x. This is you have seen in the last year. So how do you define differentiability as? Let f of x be a continuous function. It is said to be differentiable at a point C if f of x, f of c plus h minus f of c divided by h, limit as h tends to 0, exists finitely. It is denoted by f dash c. If f of x is a differentiable function, then f of x is differentiable at each and every point of the domain. This is one important point. And one more important point is every differentiable function is continuous. But the vice versa need not be true. Every continuous function need not be differentiable. But every differentiable function should be a continuous. Whenever it is continuous, then only you can define the differentiation on that. Okay? And you have studied the algebra of derivatives in the last year. That is, sum of, suppose u and v are the two functions of x, where x is an independent variable and u and v are dependent upon x. Derivative of sum of two functions is equal to sum of their derivatives. D by dx of u plus v is equal to d by dx of u plus d by dx of v. Similarly, d by dx of subtraction, difference of two variables, d by dx of u minus v is d by dx of u minus d by dx of v. And this you have studied the product rule. D by dx of u v, the multiplication of two, the product of two functions. U first function as it is, derivative of second function, plus second function as it is, derivative of the first function. Okay. Now, d by dx of quotient of two functions. This formula also you have studied in the last year. D by dx of u by v, whenever it is sin x divided by x, e raised to x divided by log x, like that. So at that, how do you differentiate that? You will not distribute d by dx to denominator and numerator. You don't say d by dx of u divided by d by dx of v. No, it's wrong. That's applicable only for addition and subtraction. As per the quotient is concerned, you will write denominator as the square of the denominator. Then in the numerator, you will keep denominator as it is. Denominator as it is, d by dx of numerator minus numerator as it is, d by dx of denominator. Okay. You have seen differentiation by the first principle method. So how you define that? Let y is equal to f of x be a continuous function. Let x changes to x plus delta x. Then y changes to y plus delta y. Then that ratio, change in y to change in x, we denote it as delta y by delta x. It is called as an incrementary ratio. If the increment in x is made very, very small as negligible, let the limit as delta x tends to 0, then we call that as the derivative of y with respect to x, and it is denoted by the symbol dy by dx. Already you are familiar with this concept in your physics. How do you define the velocity as? Velocity, you will say it as the rate of change of displacement. How do you denote it as? ds upon dt. What is the meaning of it? What is the meaning of it? The delta s upon delta t. Suppose a vehicle is moving, okay, for 100 kilometers per hour, like that. For 2 hours, it may move around 200 kilometers. If you take the difference, 200 minus 100 divided by 2 hours minus 1 hour will be the incrementary ratio. But while defining the derivative, what we say is rate of change of a function. Means for every hour the vehicle is moving, means for minute it is moving. In every second it is moving, but it is not noticed. Just like the flowers blooming. You will not notice how it is blooming, but by the morning it will be bloomed and it will be quite attractive. For example, you can take this COVID itself. In the first or 2 days, slowly its effect will be there, but it cannot be seen. That is what the derivative is. Okay, once it goes its high peak, you will notice, wow, it has gone to this level, like that. This is what the dy by dx is. Now differentiate y is equal to sine x with respect to x using the first principle method. Okay, y is equal to sine x. In the last year you have seen. Let x changes to x plus delta x. Then y changes to y plus delta y. We write it as y plus delta y is sine of x plus delta x. Okay, then subtracting 1 from 2, we get sine of x plus delta x minus sine x. We call it as an increment in y. Okay, then divide throughout by delta x, divide on both sides by delta x. Then delta y by delta x is called as an incrementary ratio. If you just take the incremental ratio, it is as good as your delta s upon delta t, change in displacement divided by change in time. But as per the derivative is concerned, for every second, for every microsecond the vehicle is moving, if you consider, you will write it as a ds upon dt. What that indicates? Limit as delta t tends to 0. When the time is negligibly small, a fraction of second, within a fraction of second also, our vehicle is moving, if it is in the moving condition. Okay, then sine of x plus delta x minus sine x divided by delta x, limit as delta x tends to 0. Then you will apply sine c minus sine d. What is the formula for sine c minus sine d? 2 into cos of c plus d by 2 into sine of c minus d by 2. Here c is nothing but x plus delta x and d is x divided by delta x as it is. You will take this 2 as the denominator for the denominator, so that it becomes delta x divided by delta x. Okay, you will write this 2 divided by delta x as the denominator for sine of delta x by 2, so that it comes like this. Okay, and then cos of 2x plus 2 delta x, it is kept as it is. Now sine, limit as theta tends to 0, limit as theta tends to 0, you know, sine theta divided by theta is always equal to 1. Here, if delta x is tending to 0, delta x by 2 is still smaller than that, means it is also tending to 0. So limit as delta x by 2 tends to 0, sine delta x by 2 upon delta x by 2 is always 1. Now in this, I will put delta x is very small, delta x is 0. Then cos x into 1 is equal to cos x. Thus, derivative of sine x with respect to x is cos x by the first principle method. Now, using that first principle, already you have derived all these formulae in your previous year. D by dx of, I'll write it as d by dx of sine x is equal to cos x. Don't read it as d sine x divided by dx like that. Okay, it is d by dx is an operator here. D by dx is operating on sine x. The derivative of and the inverse, you will write it as derivative of sine x with respect to x is cos x. Always, while you are defining the derivatives, you should use the word respect to, because there will be compulsorily an independent variable on which there is a dependent variable. D by dx of cos x is minus sine x. D by dx of tan x is sec square x. D by dx of cot x is minus cosec square x. D by dx of cosec x is minus cosec x into cot x. D by dx of sec x is sec x into tan x. D by dx of log x is 1 by x. D by dx of e raised to x is e raised to x. And d by dx of a raised to x, you know the difference. Here a means maybe 2, 3, 4, a, m like that. But here it is compulsorily e, log operator. So derivative of a raised to x with respect to x is, I write it as a raised to x into log a. Now you note some important points. If a function is differentiable at a point a, then it is continuous at that point. This is one point. Then every differentiable function is continuous. I discussed it already. The derivative of a constant function is 0. Suppose I say this is the independent variable is moving like this and dependent variable is moving like this, and the curve is constant. Whenever it is constant, what happens? It is moving at the uniform rate. That is, time is changing. But for example, if you have taken the vehicle moving, then if the vehicle is standing still here, but time keeps on changing. At that time, it is at the constant rate. Whenever it is function is constant, you will say derivative of constant is always equal to 0, because you cannot say f of c plus h. If you take here, f of c will be here. F of c plus h minus f of c, it becomes 0 only. Increment is not nothing there, so it is 0. Thus, derivative of a constant function is 0. Okay, now with this introduction to first year, we move on to the second year syllabus. In this, you are going to study these many concepts. That is, differentiation of composite functions, differentiation of implicit functions, differentiation of inverse trigonometric functions, differentiation of parametric form of equations, and differentiation of one function with respect to another. These are the concepts which you are going to study. Now, let us see the composite functions. Composite function. When do you say the given function is a composite function? Okay, suppose the function is of the form f operating on g of x. In the composition of functions you have seen, in relations and functions, you used to write f dot g as f operating on g of x. What's the meaning of it? F is dependent upon the value obtained after operating g on x. Okay, so thus these functions are also called as composite functions, and it may be the composition of two functions, or maybe more than two. So for example, f operating on g operating on h of x. Similarly, I can say suppose I have sine operating on log x. So what happens here? Sine operating on log x means our log x, I'll call this as a function, say g of x. Then sine operating on means how we'll write? F operating on g of x. So what is our f of x here? Our f of x is sine x. But what that x is, again it's a function of g of x. Okay. And here 2x plus 3 the whole square. The whole square is one operator. 2x plus 3 is one function. Okay. Then sine operating on ax plus b. You have seen the derivative of sine x with respect to x, it is 1. Is cos x, but here it is sine operating on ax plus b. Ax plus b is one function here. Sine is operating on that function. Okay, so f operating on g of x. Our g of x is what here? Ax plus b. Then sine square x. Here, if I write sine square x, what's the meaning of it? It is as good as saying sine x the whole square. It's not sine x square. That you have to make difference. Sine square x is always equal to sine x the whole square. Here sine x is one operator, one function. Then whole square is another function. Then tan operating on sine of ax plus b. Here ax plus b is h of x. Sine of some that value is g of x. Tan operating on the function is u f of x. Log of sine x. Log of sine x. Then sine x is one function, log operating on sine x. E raised to cos x is, you know, only e raised to x derivative. Here instead of x, it is cos x. Then 2 into root of ax plus b means ax plus b is one function, root of is another function. Thus, root of and ax plus b are composed in the form f operating on g of x. Now, derivative of a composite function. Derivative of a composite function is very famous as a chain rule. Why we use the word chain rule? Because we go on differentiating those one by one, one by one, one by one like that. For example, let f be a real valued function which is the composite of two functions u and v. Let y is a function of u operating on v of x. Then the derivative of y with respect to x is given by dy by dx is dy by dv into dv by dx. Sorry, du by dv into dv by dx. That is, first you will operate d by dx on this function and you will keep this function as it is. Then you will multiply that by derivative of the innermost subfunction. So the dy by dx is dy by du dv into du by dv into dv by dx. Thus, the chain rule of differentiation can be extended to the composition of more than two functions also. Now you take one example. Find the derivative of sine x square. How is the function? Y is equal to sine x square. So how does it look like? U operating on phi of x. What is our phi of x? Our phi of x is x square. U is what? Sine of. So I write this as U is sine phi. I will call phi as x square. This phi as x square, and I'll call this sine U. Got it? Then dy by dx is equal to du by d phi. That is d by dx of, d by d phi of sine phi into d phi by dx. D by d phi of sine phi, it is cos phi, into d by dx of x square. You know, derivative of x raised to n is n into x to the power n minus 1. So thus I will write 2 into x to the power 2 minus 1. It is 2x. Thus cos phi into 2x. Now you will get back to the value of phi. What is our phi? Our phi is, we have just called it as x square. So what is the derivative of sine x square? Cos of x square into 2x. It is 2x into cos of x square. Okay, same one more example I have taken, which is just correlating that. Y is equal to sine x the whole square, or we'll call it as sine square x. You note the derivative of sine of x square and sine square x. If I say sine square x, how I wrote? Sine x the whole square. Here the innermost core is sine x. I will call this function as phi of x. Then u operating on phi of x. What is our u here? The function raised to square, that is x square, or you will call it as phi square. What is our phi? Our phi is sin x. Thus, you will write it as y is a function of u of phi of x, such that this innermost function sin x is phi, and then y is phi square. What is our phi? It is sin x. So we'll get again sin x the whole square. Then dy by dx is equal to du by d phi into d phi by dx. Then you will write d by d phi of, what is u? Our u is defined as phi square. What is our phi? Our phi is sin x. So d by d phi of phi square into d by dx of sin x. 2 phi, derivative of phi square with respect to phi, it is 2 phi, and derivative of sin x with respect to x will be cos x. 2 phi as it is, cos x. What is our phi? Our phi is sin x. So derivative of 2 sin square x is 2 sin x into cos x. You note the difference between the previous example and this one. In the previous example, it was sin of x square. So it was cos of x square into 2x. And in this, it is sin square x, means you will get it as 2 sin x into cos x. Next, find the derivative of tan of 2x plus 3. Y is equal to tan operating on 2x plus 3. You will call this innermost function 2x plus 3 as phi. If you call this as phi, what remains? It becomes a tan phi. I will call that as u. U is tan phi. Then dy by dx is du by d phi into d phi by dx. D by d phi operating on u. What is our u? Our u is tan phi. So tan phi into d by dx of 2x plus 3. Tan phi, tan x derivative with respect to x is what? Sec square x. Like that, it is a secant square phi into derivative of 2x plus 3. Here 2 is a constant. Derivative of x with respect to x, it is always 1. You have studied. Plus 3 is there. You know, derivative of constant function is always equal to 0. Thus, we have only 2 here. Now, you get back to the value of v. What was v? V, we had assumed it as 2x plus 3. Thus, it is 2 into secant square of 2x plus 3. Find the next one. Find the derivative of sine operating on cos operating on x square. Here it is the composition of totally 3 functions. I will call this innermost function as w, and then cos of that w, x square is w. So it becomes cos w, and then sine of, I will call this cos w as v. So it is a sine v. Thus we have sine v, where v is cos w, where w is x square. Like this will split. Then dy by dx is du by d phi into d phi by dw into dw by dx. Like this one, right? D by d phi operating on sin phi, it is cos phi. D by dw operating on cos w, it is minus sin w. D by dx of x square, it is 2x. Cos of w into minus sin of, what is w? W is x square into 2x is there. So cos of cos x square into minus sin x square into 2x. So we have minus 2x into cos of x square into sin x square is the derivative of the given function. Now you have some examples in the exercise. You please try to solve these exercise examples. First one, derivative of sine of x square plus 5. Okay. In the previous examples, I have just given you the theory. Now you can directly start differentiating. Sine of x square plus 5 means sine of x square plus 5. Derivative of sine of, you write it as cos of. And the x square plus 5 function, you keep it as it is. Then you multiply it by d by dx of that value, x square plus 5. Got it? Sine of x square plus 5, derivative will be cos of x square plus 5 into d by dx of that innermost function. What is the innermost function? X square derivative is 2x plus derivative of 5, it is 0. Thus we have 2x into cos of x square plus 5. Second example, cos operating on sin x. Y is equal to cos of sin x. D by dx of cos of sin x means cos of derivative will be minus sin of, you will write. Minus sin of, whatever the dx sin x is there, that you will keep it as it is, into d by dx of that innermost function, d by dx of sin x. Thus, minus sin of sin x into cos x. Next you have sec operating on tan root x. Sec of tan root x. What is the derivative of sec x? Sec x into tan x. Like that we have sec of tan root x. Sec of tan root x into tan of tan root x into d by dx of tan root x. That is sec of tan root x, tan of tan root x. Then derivative of tan is what? Tan x is the derivative of tan x with respect to x will be secant square x. Like that tan of root x means I will write secant square the function as it is. It is root x into d by dx of root x. What is d by dx of root x? Root x means what? It is x to the power 1 by 2. You know, d by dx of x raised to n will be 1 by 2 into x to the power 1 by 2 minus 1. 1 by 2 minus 1 means minus 1 by 2. Minus 1 by 2. Root means 1 by 2. Minus 1 by 2 is there, means you will write it as 1 divided by, in the denominator you will write it as root x. Then cos of root x. D by dx of cos root x. Cos of derivative is minus sin of. The root x you keep it as it is. Into d by dx of root x. What is the derivative of root x? 1 upon 2 root x. Thus we have minus sin root x divided by 2 root x. Then y is 2 into root of cot x. Here root of is one function here. Root of. So root of if we take, then what is, you already have seen the derivative of root x is 1 by 2 root x. Like that there is a function v means 1 divided by 2 root v. Thus it is 1 divided by 2 into root of, what is the function? Cot x. Then d by dx of cot x square. 1 divided by root of cot x square into, what is the derivative of cot? It will be minus cos x square. Then what is the derivative of x square? You will write it as 2x. Thus we are going to differentiate the functions 1 by 1, 1 by 1. Hence the name chain rule is. Now you have one more function in the quotient form. Sin of ax plus b upon cos of cx plus d. You will use the formula for derivative of u by v. D by dx of u by v means what you will write? Denominator is the square of phi square. That is cos of cx plus d whole square means I will write it as cos square cx plus d. Cos cx plus d as it is into d by dx of numerator. It is there minus numerator as it is d by dx of denominator. You will simplify and get the answer. Like this. With this composite functions I have explained. Try to solve the exercise problems. In the next class we shall solve some more examples on composite functions, and after that we shall start with inverse trigonometric functions. Derivative of inverse trigonometric functions. Okay, thank you.